This is going to be a short video lesson for section 4.7, which is called Estimating Roots. Now, so far we've talked about solving regular radicals that have perfect squares in them. For example, let's take a look at the first two. On the far left we have the radical, and again I didn't write the power of 2 here, but you assume if there's nothing there that it's a radical of second power. So here we have a radical of second power, and underneath it we have a 25, which is a perfect square. So can someone tell me what I would do to solve that first, or simplify that first radical? If you said I can write the 25 in its exponential form, I would agree with you. I can take, so I'm going to rewrite the radical of second power, and I can write the 25 in its exponential form, which is in this case either 5 times 5 or negative 5 times 5, or negative 5 times negative 5. And I'm going to choose the principal square root, which is the positive one. So 5 times 5, or 5 squared. And once again, because this is a radical to the second power, what I can do next is cancel out the second power of the radical and the power to the 2. So I can do this. Gone, gone, which of course leaves me with just the base 5. That's my answer. So we did this in the last section. Let's take a look at the middle problem there, which is the radical of second power. Again, the 2 isn't written there, but you assume it's there. If there's nothing there, it's a 2. And underneath it, we have 36, which is another one of our perfect squares. I'm going to do the same thing. Can someone tell me what is the principal exponential form of 36, the positive exponential form of 36? If you said 6 squared, or 6 times 6, you're absolutely correct. Obviously, negative 6 times negative 6 works as well, but I asked for the principal one, which is the positive. So, of course, I can write down 6 to the second power. And then because this is a radical to the second power, radicals and exponents of the same power cancel each other out. Gone and gone. And I'm left with just the 6. Any questions on those first two, because they were kind of a bit of a review? Alright, then let's take a look at the last one. Here you're also asked to find the root answer. But unlike the first two, 30 is not a perfect square. There are no two numbers, or at least no two integers, when multiplied together. There are no two identical integers when multiplied together will give you 30. Sure, you can multiply 5 times 6, 3 times 10, 1 times 30, and a bunch of negative numbers, or the negative versions of those as well, to get 30. But no two identical integers when multiplied can get you 30. You can't do 6 times 6 or 5 times 5. There are some fractions and decimals will work, but again, it has to be an integer to be a perfect square. So what do we do here? Well, you can estimate. You can estimate what would be a possible answer for this. And the way we do that is we first look at what are the two closest perfect squares to 30. I conveniently gave you the closest two perfect squares right there on the same page as the first one's a bit of a practice. 25 and 36 are the closest two perfect squares to 30. 25 is the closest smallest perfect square, and 36 is the closest larger perfect square. So 30 falls right in between those two. There's no other perfect squares that are closer to 30. So, and conveniently, we already worked out 25 down to 5 and the 36 down to 6. So in cases like this, where you have a radical of the second power, and underneath the radical you don't have a perfect square, you estimate it using the two closest perfect squares, one that is immediately below it, one that is immediately above it. So my number, or my answer for 30 is going to be somewhere between the radical of 25 and the radical of 36, or between 5 and 6. So my answer for this is going to be somewhere in between 5 and 6. So somewhere in here. Now I don't know exactly what it is. It's going to be 5 point something. But to keep it simple, because it's in between 5 and 6, I'm going to say that my answer is 5.5. This may not be 100% accurate, but since we're estimating, this is going to be good enough. So my answer is between 5 and 6. 30 is pretty much right in between. It's a little closer to the 25 and the 36, but overall, it's about 5.5. And that's going to be good for me. So that's how you estimate square roots, when the number underneath the radical is not a perfect square. You find the two closest, one below, one above, find out what the answers of those two are, and then just plug the estimate right in the middle. Let's practice. All right, let's take a look at the one on the left here. And we have a radical to the second power. Again, I didn't write the 2 here. You assume there's a 2 there if there's nothing there. So it's a radical to the second power. And it's 43 underneath. Now, 43 is not a perfect square. There are no two identical integers when multiplied against each other, positive or negative, that will yield a 43. So your job, if you want to estimate this, is to find the two closest, one above, one below, that are perfect squares. So can someone tell me what is the closest perfect square that is just smaller than 43? If you said 36, you're absolutely correct. So the radical to the second power of 36 is immediately below the 43. There's nothing in between 36 and 43. So right below 43 is the perfect square 36. Can someone tell me what is immediately above 43? What is a perfect square that's just larger than 43? If you said 49, you're absolutely correct. So the first step to estimating is to find the two perfect squares that are immediately below and above the one we're trying to estimate. So we did that. Now you find the simplifications or the answers to these two. What is the square root of 36 and what is the square root of 49? Can someone tell me what the two of those are? Well, 36, I can simplify that down into 6 squared. So if you said 6 and 7, you're correct. And 49, I can get that down to 7 squared. I apologize if you hear my dog barking. And since I can cancel out the radicals, my individual answers are 6 and 7. So since I'm trying to find an estimate, and I know my answer is going to fall right in between these two because the 43 is bigger than the 36 and smaller than the 49. It's a little closer to the 49, but again, for simplicity's sake, we're going to say it's somewhere in the middle. So what's in the middle of 6 and 7? 6.5. And that's my estimate. Again, it's not precise. It's probably closer to maybe 6.6, but that's good enough for us. Does that make sense? Questions? Perfect. Let's do another one. The 12. Can someone tell me what are the two closest perfect squares? One above, one below 12, because 12 itself is not a perfect square. There are no two identical integers when multiplied that can get us 12. We can go 3 times 4, 6 times 2, 1 times 12, but they're not the same. So what are the two closest? One below, one above. Well, if you said the one below is 9, because that's 3 times 3, and the one above it is 16, 4 times 4, you would be absolutely correct. Next step, what are the two simplifications of the radical of 9 and the radical to the second power of 9 and the radical to the second power of 16? What are those simplified to? Well, 9 can be written down, well, the answer should have been 3 and 4, but 9 can be written as 3 squared, and 16 can be written as 4 squared, which of course then can cancel out with their radicals, since they're the same power, power of 2, gone, gone. So of course that leaves us with 3 and 4, and I know my estimate should be somewhere in between these two. 12 is bigger than 9, but it's smaller than 16. So what should my answer be? Approximately 3.5. This is not going to be precise, but it's approximately 3.5, between 3 and 4. That's simple as that. Any questions on that second problem? All right, let's do 2 more and then we're done. So it's going to be a pretty simple and short lesson. All right, 71. Again, it's not a perfect square. There are no two integers when multiplied, or at least no identical integers when multiplied that'll get you 71. But what are the two closest perfect squares? Well, on a small scale, we have right below 71, 64. On the larger scale, right above 71, we have 81. Those are the closest to, one above, one below. And I'm not going to do the simplifications. What is the radical to the second power of 64? It's 6 times 6, or 6 squared, so the power of 2 and the radical would cancel each other out. So it's just 8. Wow, I'm about to write. It's not 6, it's 8 squared, 8 times 8, so it's, my apologies. So this would be 8 squared, cancel with the radical, so the answer is 8. So that's what I get for taking shortcuts. What about the 81? 9. 9 squared, cancel the radical with the power of 2, so I'm just left with a 9. Okay, and since my 71 is right in between the 8 and the 9, what would be my final answer? Approximately 8.5. Between 8 and 9. Let's try the last one. 90 is not a perfect square. Again, no two identical integers can get us 90 when multiplied. I mean, yeah, there's 9 times 10, there's 2 times 45, but no two identical integers. So what are the two closest perfect squares? One below, one above. If you said the one below is 81 and the one above is 100, I would agree with you, like totally. Dude. All right, if I were to simplify the radical to the second power of 81, what would I get? You don't have to look very far, I already did it here. A 9. What about the 100? What times what gives me 100? That's identical. 10, of course. And since my 90 is right in between the 81 and 10, the 81 and 100, my answer is going to be right in between 9 and 10. And what's right in between 9 and 10? 9.5. Simple as that. All right. That's it for that lesson. Questions? Thank you.